In this video, we're going to look at hypothesis testing, and this is a similar example as you might see in our textbook 7.2. So we've got a coffee company that claims their coffee has at least 100 milligrams of caffeine per cup. A random sample of 28 cups has a mean of 94 milligrams of caffeine, and we'll assume the standard deviation of the population is 20 and let alpha equals 0.08. We want to know, is there enough evidence to reject the company's claim? Okay, so the first thing is, let's go through and write down what these numbers are and talk about what they mean. So first of all, we've got a sample of 28 cups, so that gives us an N value of 28. So that's right there. The next thing we notice right here is that our sample has a mean of 94 milligrams of caffeine. So that's what we're going to call X bar. That's the mean of our sample. And the company is claiming that the mean of their coffee in general is 100 milligrams of caffeine. Okay, so what else do they give us? They also give us a standard deviation. The symbol for standard deviation, for population standard deviation, is sigma. So we're going to assume sigma is 20, and alpha is 0.08. And I want to talk a little bit about what that alpha means and how it's going to play a role into our calculations. All right, so let's take a look at a picture in general. So here's a picture of a normal distribution, and the normal distributions also look like bell curves. And in the middle of the bell curve here we've got our mean, and a lot of times we talk about how far from the mean we are, and we measure that in terms of standard deviations. So for example, if we wanted the mean plus 1 standard deviation, that would look like mu plus sigma, or the mean minus 1 standard deviation would be mu minus sigma. And we know from our study of the normal curve that between those 2 points there, we've got 68% of our data lie in here. Right? And we can go out 2 standard deviations and talk more about that. 3 standard deviations and so forth. And so, kind of what's interesting here is that even if the null hypothesis here is true, 68% of the time we're going to go in and measure points that are wiggling all around in here. So sometimes we go measure a sample and it's going to have, far less caffeine or far more, but we're still within the what I call acceptable wiggle room. We're still pretty close to the manufacturer's claim. And so when we're testing these sorts of claims, what we want to know is, are we way out here in some extreme tail? We're looking to see, is our sample really extreme compared to the claim? And that's really the framework. All right, so let's make this a little bit more precise. Let's give ourselves a null hypothesis and an alternative hypothesis. So our null hypothesis is going to be that mu is greater than or equal to 100. And this is our claim, or rather the manufacturer's claim. Right? And when we're done with our hypothesis testing, we can either reject the null hypothesis or fail to reject the null hypothesis. All right? And the reason why it's greater than or equal to is because of this phrase right here, at least. So it could be 100 or more. And then the alternative hypothesis has to be the opposite of that, so we're going to say mu is less than 100. Okay, so this is going to give us a one-tailed test. And the reason that this is a one-tailed test is because there's an inequality in here. If it's equals and not equals, then you've got a two-tailed test. But there's a little picture you can use to keep in mind here. Look, at your alternative hypothesis has an inequality that goes in that direction. And if I draw this kind of looking like a alligator or some creature here, and there's its tail. Okay, that's my alligator looking creature. So there's that inequality, right? Going the same direction as our plane there. And the tail is over here at the left. So the tail is pointing to the left. If it was an inequality the other way, the tail would be going to the right. But we've got a left tail test. All right, so we want to know, is our data way over here? Is our data point some sort of extreme event over here in the left-hand tail? Okay, so let's take a look at what we've got here. We'll draw a new picture. And we've got our normal curve. Okay, and we've got a mean of 100. And we want to know, is our average value down here in this extreme tail region, and this area here is supposed to be 0.08, or is this 94 score, is it sitting somewhere up in here along with 92% of the points? Okay, so the first thing we need to do is find a cutoff value or a critical value, a z-score that we're going to use to determine, hey, we're either in the rejection zone or we're not in the rejection zone. So let's find our critical value. Okay, so we're looking for a z-score that is associated with 0.08 under the curve. I'm going to hop over to a z-score calculator here. And this website I've posted in the course. I'll just bring it down here so that the URL is in the screen. And so what we want to do here is we want to scroll down and we want to find a z-score associated to 0.08. Okay, so I'm going to type in 0.08 right here. And that's going to give me a z-score of negative 1.41. Okay, so that's my cutoff, negative 1.41. If I am more extreme than 1.41 standard deviations below the mean, we're going to reject the null hypothesis. Okay, so let's write that down. This is our rejection region. We're going to reject the null hypothesis if our data lands in that zone, and we will fail to reject the null hypothesis if our data lie in this other 92% zone. Okay, so let's compute our z-score. Our z-score formula is going to be x bar minus mu divided by the standard deviation over the square root of n. So for us, that's going to be a 94 minus 100 over 20 divided by 20 square root of 28. And when we type that into the calculator, we need to account for some parentheses here. We want to do parentheses 94 minus 100, close parentheses, divided by parentheses 20 divided by square root 28. Close the square root parentheses, and let's close the parentheses for the denominator. And it's really important to type it all in on one line of the calculator, otherwise you're going to start getting rounding errors at each step of the calculation. So here's how I would type that in. I'm going to hop over to a program called Wolfram Alpha. I like this program a lot because it shows you what the computer is interpreting as you type it. Okay, so there we've got all our parentheses, and we hit enter. And when we do that, it shows us what the input was. That's what we wanted, so that's good. And then it gives us a decimal approximation which was negative 1.59 if we round. I'll go back here and write that down, negative 1.59. So our data point from our experiment or our data collection exercise of these coffee cups lies right in here. Right? There's our negative 1.59. So we are in the rejection zone. And at that point, we will reject the null hypothesis. Okay, so our conclusion here is we will reject the null hypothesis. So is there enough evidence to reject the company's claim? Yes.